Gracias, Juan. Y gracias a todos para estar hoy conmigo en la Día de Independencia. Estoy muy encantado de tener esta oportunidad. Desafortunadamente, como ustedes pueden escuchar, mi español no está bastante bien para hacer toda esta presentación en español, y entonces voy a hablar la mayoría en inglés. Y tengo un poco mis capacidades en inglés están un poco más mejor que en español. Okay, so let me go ahead and share my screen here. Now let's go over to, here we go. Excellent. So what I'd like to talk to you about today is, as a physics textbook author, is about some of the laws of writing physics textbooks, but these same rules apply actually to other subjects as well. But I think given the disciplines that you're all in, you all will certainly be exposed to physics whether you want to be or not. And so a lot of the same rules sort of apply there. And if you want, you can follow me on Twitter, and you can also follow me on Instagram as well. And there's my email address for you as well. Actually talking to you today from the campus at UC Santa Barbara, which is a small distance away from Ciudad de Mexico, over here on the Pacific coast. And we always have to show a photograph of the campus. So let's say yeah, and actually the physics building where I am is sort of over here on the right here. So you can see that it's actually an easy walk for the students. So the student residences is actually quite easy for them to walk down to the beach to go surfing and so on. So, but as you can see, given that we're in a pretty small area, it's also have a lot of students, about 26,000 students, and actually several thousand students a year will actually take physics at UC Santa Barbara. As your professor was saying, I certainly had experience with writing a number of textbooks over something I started on actually in the 1990s. Many of you will hopefully have experience with my book, Física Universitaria, in translation in Spanish. There's the original English version in the middle, University Physics, but I'm also author on this college physics book and also on some astronomy textbooks as well. So it's interesting, and it's also very different than other kinds of writing for the sciences. So in my experience, if you want to be able to write physics textbooks or textbooks in any academic subject, you first have to become an educator in that subject. You have to know not only the subject, but you have to be able to present it to other people. You have to understand what kind of difficulty students have with the subject. I'm sure you've had experience with your own textbooks where sometimes they've been written in such a fashion that it's difficult to follow what's going on because the author did not have a good sense of what the problems are that students encounter with the material when they see it for the first time. So having lots of experience teaching the material is a tremendous help in that regard. But if you want to teach a subject, you also have to become an expert in that subject. So that means that to become a physics educator, you also have to become a physicist. So that's actually what I did to get to where I am now. So I actually did my undergraduate work at UCLA, University of California, Los Angeles. And after getting my bachelor's degree there, I went on and did my PhD in theoretical nuclear physics at Stanford University. And then from there, you think, okay, now you're done, now you're a physicist. Well, not quite. After that, I did a 3-year postdoctoral research at the University of Washington in Seattle. And then after that, I said, okay, you're more or less a physicist. And that's when I actually came to UC Santa Barbara. So while I originally came to Santa Barbara primarily to do research, over the years that transformed into mostly doing work in physics education, and then from there actually going into writing textbooks. And the way I got into writing textbooks was, if you're a physics professor, you're often asked by the publishers, oh, we have a new book coming out, would you like to review it? And so I wrote a number of reviews, and people actually liked what I was doing. And so as a result, they said, oh, we like what you're doing. Would you like to actually try writing something for us? And that's how that whole thing evolved. As a physicist, of course, or any scientist, and anything in science or engineering, you get to write research papers. And those research papers you're amazed actually to see that in a way that anyone reads them at all. This is one paper of mine from many years ago, and I look and, oh, somebody cited it like last year or the year before. So I know at least 2 people read this paper. And so it's certainly a big part of becoming a scientist, is learning how to write research papers, but the skills involved with that and the skills involved with actually writing a textbook are actually quite different. So for most of what I'm going to talk about today, I want to actually discuss the differences between writing a research paper on the one hand and actually writing a textbook on the other hand. And while there's certainly some similarities, nonetheless, there's a lot of differences. And then I'll leave lots of time at the end for you guys to pose questions. So for instance, in a research paper, they're usually written in a very formal way, using the so-called passive voice. So you might say, oh, in our analysis, the samples were analyzed using the method of Tecnologico and so on. And that's okay. You read that and say, okay, this is pretty boring. See if you can stay awake for that. But in a textbook, you have to keep the students involved and interested. And so there, you'll try to write in a friendly tone that's bringing them alive. So instead, you might say, okay, well, let's look at the method that Tecnologico and her collaborators used to analyze their samples. So you want to make it more conversational so that the student feels like that the author is having a conversation with them. So the less formal actually that a textbook is, the better it is, and the more likely are that students will actually pay attention to it. Another issue you have with research papers versus textbooks is with writing a research paper, you can make a pretty good assumption that if someone's going to go to the effort to read this paper, either in a physics journal or reading it online, that if they're interested in the subject, you'll assume they know something about the subject. They may not know all the details, but at least they know enough to understand at least your abstract and probably understand the conclusion. And if they're really interested, they'll read the middle part as well. But you can always assume that there's sort of a basic level of understanding that your readers will have for any research paper that you would write. If you're an engineer, if you're writing a technical report to be used within the company, same thing, you can assume that people know what the product is you're talking about, what the issue is, and so on. For textbooks, you have no such, you're not allowed to believe that at all. In fact, it turns out with a textbook, it's not just you have to assume the students don't know anything. You have to assume they have an understanding and it's wrong. For instance, in teaching physics, there's lots of research that shows that when students come to take their first university physics class, they're all experts in physics. You might say, how can they be experts in physics? They may never have taken physics before. But by the time they get to university, they've had at that point at least 18 years or more of experience in the natural world. They've had experience throwing balls, kicking balls, turning switches on and off, plugging things into the wall, and so on. And the research shows that as a result of that real life experience, they've developed a common sense picture of the physical universe, and most of it is wrong. So for instance, the way they think that most people think motion works has nothing to do with laws of motion as written down by Isaac Newton. Instead, they have these ideas that are much more ancient, much more primal, and much more incorrect. So for instance, if you ask the average introductory student, okay, a car hits a wall and stops, why does the car stop? If you're a physicist, you'd say, oh, well, what happens is it's Newton's third law of motion, action and reaction. The car hits the wall and pushes on the wall. The wall responds by pushing back on the car, and the pushback is what makes the car stop. If you ask the average untutored student, one who hasn't taken any physics yet, but just has common everyday experience, why does the car stop? The answer that most students give, which is amazing, is, oh, the wall got in the way. Okay, that's fine. And that's a picture of the universe, but it's not the one you learn about in physics because it's not enough. So in a way, writing textbooks for the sciences is harder than writing about some subject that the students are completely ignorant about because they have so many incorrect ideas. You not only have to teach them the correct ideas, you have to convince them that they have these incorrect ideas and they're wrong. So for instance, in my books, I will put in these textbooks, the cuidado paragraphs that alert students to common mistakes and common misconceptions. So this one, for instance, is about the idea of acceleración. For many people, acceleración just means your speed is increasing. But in physics, that same word can mean your speed is increasing, your speed is decreasing, or simply that you're moving in a different direction. So if either the direction or the speed changes, then that constitutes an acceleration. So this is alerting the student to that particular misconception about what acceleration means, and so they know not to have that problem in future. So again, that's another big difference you find with doing a research paper or a technical report compared to writing a textbook, which is that you have to convince the students that they have these misconceptions, and you have to alert them to these misconceptions. By the way, this is an idea that I got not from reading other physics books and not from seeing some research on this. It's actually an idea that I got from comic books. And it's an idea that actually goes back to one of my favorite comics from when I was small, the comic called Strange Adventures with these science fiction stories. I particularly like this cover for your professor. This is, I think this is Murphy Anderson as the artist here. I love the aliens with ears like butterflies, which is really cool. They're capturing airplanes. But one of the features they had in this, besides the science fiction stories, was a series called Science Says You're Wrong If You Believe That. So they actually confronted some of these exact misconceptions. So these are actually a couple of physics misconceptions, for instance, that people have about motion, and the second one is about planetary motion. So, and that's an idea that stuck with me for many years, saying, oh, there are these misconceptions. It's important to be able to confront those. And that's something I've actually adopted in my textbook writing. Again, something you would never quite have to do in writing a research paper, but something that's very important in writing a textbook. When you're writing that research paper, for instance, of course, what goes into a research paper? We look, it's a lot of text, and there's equations as well. And sometimes people are surprised who are not in the sciences to look at these even research papers and say, I thought it'd be all equations, but no, it's more words than it is equations. There's more text than equations, but there's also figures. And we all know how important the figures can be in explaining things. Well, that's one point where you actually do get to do the same with a textbook. Namely, there's textbook, there's the text, there's equations, and there's figures, but you need a lot more features than that. So, and those additional features, and I'll show you some examples of those, they're there in order to help your students, your readers, master the material. So what are some of the features that I'm thinking of for this? Well, one, for instance, that comes to mind is just the equations themselves. Equations themselves can be very confusing to students, certainly at the beginning, because they see all the symbols and say, wait, what does that symbol mean? What does the Q mean? What does the F mean? So when I write equations in a textbook, I actually like to label the equation. So if a student doesn't do anything but just look at the equation, if they're in a hurry and they look at the equations, they can at least remember, okay, what is all this about? So this is actually the formula for the force between two electrically charged particles separated by a distance, and what's the magnitude of the force that acts between them. And so here's the formula written out and a reminder of what each of those symbols mean. So having something like this, I find for students goes a long way toward helping them understand these otherwise fairly complicated sorts of equations they'd be dealing with here. Another example is on figures as well. I will very often add explanatory text to the figures. So here's one about the concept of torque and trying to understand what happens when trying to rotate this bolt using a wrench, and the idea of the right-hand rule for figuring out the direction of the torque. So adding labels like this, adding arrows to show the students adding these annotations to the figures, I find goes a very long way toward improving student understanding. So whenever you're creating figures, whenever you're writing down equations, think about what are the ways you can make these easier for students to actually understand. There are other features that you add that are completely different than what you would find in a research paper. So I've shown you an equation and a figure. You find those in research papers. I've just modified them to make them more friendly and more understandable to students, but there's other features you add as well. So for instance, one thing that you'll find in all my books are the strategies for having students learn how to solve problems. And I remind students that so much of what you do in a science class is learn how to solve different types of problems. And so I actually identify, in this case, 4 different steps: identificar, plantear, ejecutar, and evaluar, and pointing out that every part of that is important and here is an example of doing it for a particular type of problem. These are ones on la conservación del momento lineal, and pointing out to students that if you follow these steps for every problem, you'll be able to solve the problems in a much more sensible fashion. So often students see the way that professors or other scientists will solve problems and think that that's magic, it's complete magic. And this is showing it, in a sense, it is magic, but this is showing how the magic is done and reminding them, and in fact, it's not just a matter of getting the answer. That last step, evaluar la respuesta, is very important. Look at that and say, does your answer make sense? Does the number make sense? Does all this make sense physically, and so on? And so, again, features like this are very important for helping the students understand not just what the subject matter is, but how they can actually use it. That's a different, by the way, from a research paper. Usually in a research paper, you'll tell people how you did it, how you got the results, but they're usually most interested in the results. But in teaching and writing a textbook, you're not just interested in the students knowing what the result is, they're interested in them knowing how to solve the problem themselves and how to solve different problems themselves using the principles that you present in the textbook. And so because that's so important, it's important to give the students these kind of opportunities to understand what are the techniques for solving problems. And then you don't just tell them what the techniques are, but you show them examples of using that. Here's an example, for instance, of using that same kind of steps. And I've just shown a portion of this for solving this ejemplo in the theory of special relativity. And I think there is a law, by the way, if you look at the two people sitting in chairs, any problem that involves special relativity, one of the people has to be Albert Einstein. You can see him there with his white hair. So having worked out examples in the book, and there's probably several hundred of these in the Física Universitaria book, showing students how to solve a problem, giving an example of how to do this, something that's actually very important. And in fact, for me, if the student just looked at the equations, read those outlines of how to solve problems, and did the examples, that's most of what I would like them to get out of the book. And if they actually read the text as well, that's okay too. But being able to do this stuff, I find, is incredibly important. It's also important to test not just their ability to solve problems like that and to show them how to solve problems, but also in the text to give them a chance to test their understanding. So here's one of those test your understanding or evalúe su comprensión questions, in this case, of one of the sections in the book. And you give the student an example of here's something based on one of the figures in the book. What if things were a little bit different? How would things change? Then they have to decide, okay, which of these is the correct answer? And if they look at the end of El Capítulo, they'll actually see what the answer to this question is. But it gives them a chance to check their comprehension and really see what's going on there and test what their understanding is. That's certainly nothing you would put in a research paper, but it's very important for students. And if they get to this and they say, I didn't understand this, I didn't get the right answer, you can suggest to students, well, maybe you should go reread the section or check with other people in the class, check with your professor, and so on. But giving students these checkpoints, I find, is really incredibly helpful. Another difference with research paper and textbook is, in a way, writing a research paper is easy because you're writing for just one kind of audience, one group of readers, and that's the other scientists or engineers who are interested in your field of research. Because if they're going to pick out a paper on this one particular topic, you have to assume they're already interested in that subject already, and again, probably know something about it. So you know something very intimately about what your audience is like. For a textbook, it turns out you think, okay, well, the audience is students, right? Well, that's one of your audiences, but it's not the only one. And in fact, for writing a textbook, there are actually 3 different audiences for whom you have to write that book. One of them is, in course, the students, because the students who you hope will read the book, and you're writing all those features of the book for the benefit of the students. But notice something interesting about textbooks compared to other kind of books. For instance, if you want to go read a roman, no one tells you which one you want to read. So what would you do? You go to the bookstore, you'd go online, and you'd search through and say, oh, here's an author I like, or oh, this looks like a good story, or oh, someone told me this is a good book, and then you choose the book yourself. For textbooks, you usually don't have that option. For textbooks, who chooses the book? It's the professor, or sometimes a committee of professors. And so that's your second audience. You have to write the book so that it has features that will appeal to the professors who will choose the book. So you really have to alert the professors about, and in fact, if you look in the introduction to most books, it has a list of what the features are. That list of features is not for the students, it's actually for the professors who might actually want to adopt the book. And so you have to make sure that as you create those features, they have to be done in a fashion that other people in the field who'll be teaching the class will be interested in the features that you created. And there's a third audience as well. You might say, well, who else is involved? There's the students and professors. Who else is there? Well, in order for the professors to choose the book, they have to know about the book. And how do they know about the book? Marketing. Someone has to tell them about the book, advise them of the features, and help them with actually implementing the textbook. And so that's your third audience. It's the sales representative. Each publisher has a group of sales representatives actually all around the world. I've actually had the opportunity to meet several of the sales representatives for Física Universitaria in Mexico. And they travel all over the country, working with professors here and there, saying, oh, you've got the book. What supplements do you need? Do you need the PowerPoint slides and so on? And so when I write the book, I have to think, okay, which of the features that I'm adding will the sales representatives be able to explain to the professors? The sales representatives are not experts in science. Usually they don't have science degrees at all, because they may be selling books in physics, books in chemistry, books in literature, books in history, and so on. So you have to write features in such a way that they can understand, okay, here's what this feature does and here's why it's important. You may not understand the physics, but here's an example of a misconception. And for instance, so that's why I have these cuidado paragraphs to explain to students why that's an issue. And so it's kind of remarkable writing for not just a single audience, but for this sort of triple audience. So again, lots of differences between research papers and textbooks. Just like learning how to write a research paper is like everything in science, it's a process of experimentation and working to see what works. The same thing is true for textbooks. So I'm always experimenting, trying to think what are new and different ways to actually create things. I'm not going to give you any details, but actually your professor and I are working on an interesting project right now, a totally unique way of teaching physics. And I'm not going to say anything more, except to say that it's going to be both in an English version and a Spanish version. So hopefully in a couple of years, you got to see what that's about as well. But I will give you no more information about that now. What I will do is say that this is actually a good time for me to pause and actually open things up to any questions you might have. So I'll pause things there and I'll thank you for your attention.